Good morning, afternoon or evening. Welcome back to the second video on Zero Trust architecture and Zero Trust networking. My name is Tony Kirkham. In the first video I attempted to decipher Zero Trust, what it was about and the benefits it provided. And as I said in that video, it's in the architecture and deployment approaches where my real interest lies. So I want to now move on to a slightly deeper coverage of the potential architectural approaches. Then in a third video, I'll provide some practical deployment guidance. But I want to start by quoting some of the key elements of the NIST Special Publication 800.207 to set the scene. Zero Trust is the term for an evolving set of cybersecurity paradigms that move network defences from static, network-based perimeters to focus on users, assets, and resources. Zero Trust assumes there is no implicit trust granted to assets or user accounts based solely on their physical or network location. Zero Trust focuses on protecting resources, not network segments, as the network location is no longer seen as the prime component to the security posture of the resource. Let's now look at the architectural definitions which I have taken from NIST Special Publication 800.207. In the first video I noted Zero Trust defines the concept of a policy enforcement point, the PEP, and a policy decision point, the PDP, where they conceptually reside between the user and the target resource. It works a bit like a security checkpoint at an airport. A session is authenticated and authorised based on some set of criteria. Then when it's considered sufficiently trusted, it's allowed through to the target resource. In practice, the policy decision point and the policy enforcement point have quite separate functions. The policy decision point can be broken into a policy engine and a policy administrator. These are what determines and centrally controls the security policies. In the diagram you will note the concept of a separated data plane and control plane. And this is a concept which comes from telco architecture. So basically the policy decision point controls the actual data plane traffic, and any of the overarching policy determination is handled by the policy engine and the policy administrator. And this gets pushed down to the policy enforcement point, which acts on the traffic trying to access the target resource. But this doesn't just work in isolation. Both other systems and policies integrate with or provide input into the solution. So these include things like continuous diagnostics and mitigation, industry compliance, threat intelligence, activity logs, data access policies, public key infrastructure, identity management, and SIEM systems. These are all elements which require consideration within an overall design. In the first video, I introduced the general architectural directions, so I want to now have a slightly deeper look at each of them. So let's start with the most traditional, of network segmentation or microsegmentation. This approach is probably the most applicable to many. So typically this approach will use next generation firewalls as the policy enforcement point. These days virtually all next generation firewalls have some form of application ID and identity capability which can be used in place of the far older 5-tuple base rules. So for next gen firewall segmentation, I'm sure most people are familiar with the concept of segmentation, where we place individual systems within an application architecture into appropriate security zones or enclaves. So with respect to Zero Trust, the level of admission and inspection needs to be far higher than we did with the traditional 5-tuple rule-based approach. So this is the never trust, always verify approach. So if users are accessing a data center or cloud resource, they will need to utilize some form of strong identity to prove who they are ahead of the connection being permitted. So if it's an application stack, then approaches like validating certificates or some form of the emerging identity-based technologies, something like comes from the company Apparato, could be used to positively identify each element of the application architecture, not just virtual machines, but containers as well. Then the verify part can be done by applying the additional inspections, like IPS, network antivirus, threat intel, possibly deep packet inspection, DNS request inspection, things like that. And these are all typical next-gen firewall functions. So next-generation firewall segmentation. What might a simple deployment look like in practice? And I'll emphasize this is very oversimplified. So let's look at it in principle. So this is just one example only. So we have a next generation firewall of the data center perimeter tied into Active Directory. Out in the enterprise somewhere we have both users and administrators, and those will be authenticated by Active Directory. A couple of example rules. So in addition to the source IP address, we identify both the application, HTTPS, and the user's ID before they are permitted to establish a connection. So a similar thing for identified members of the administrator's AD group. We allow them RDP access coupled with a tightly restricted address range. Again, this is just an example, but then on top of that we apply all the additional inspections, IPS, network antivirus, threat intelligence, etc. can be all applied at the next-gen firewall. Let's look at a variation of the same theme. If we were to use 802.1x for network admission control, that provides a strong identity function, possibly through the use of machine or user certificates. So once successfully authenticated, the user's device through either a wired or wireless media gets access to the network. Then through that same process, if we use Cisco's ICE, we could assign a scalable group tag to each user. And then it's possible to simplify the firewall security policy or rules to business logic based on those security group tags. So the security policy administration process becomes very elegant and easy. Something like, so in this example, we're permitting HTTPS and the source based on a security group tag, general staff, to gain access to a destination security group tag of protected asset. And then for administrators, permit RDP and a source of security group tag with administrators to the destination protected asset as well. So my question here is, does this fulfill the zero trust requirements? I believe that it does. And this is an approach which can be done reasonably easily right now. Let's talk about host-based segmentation. The variation on the firewall-based micro-segmentation theme is the use of host-based firewall rules, either in place of or in addition to physical or virtual next-gen firewalls. The two most prominent examples of this in the market is Cisco with Tetration and Illumio. Essentially the way this approach works is an agent is deployed on each server, which in turn controls the server firewall, typically either IP tables or Windows firewall. A centralized controller then communicates with each of the agents to program each of the server firewalls. So we have a centrally controlled, highly distributed firewall approach. In concept, you have something like this, a very granular control at the individual server level. And from a deployment perspective, this type of approach can work with systems in their current network locations and doesn't require readdressing and all of the logistical issues associated with doing that. The additional benefit is that you can gain very fine-grained traffic visibility at each host level. And this is a big advantage from both a design and an operational perspective. But it's also a big data problem due to the capture and the sheer volume of the traffic information which can be generated from such a system. In practice, both approaches can be combined. A next-gen firewall is far more functional with application ID and the additional inspection functionality. But whereas a host-based approach is typically limited to a 5-tuple-based policy, but far easier to implement and spread across a wide area. So a hybrid approach makes a lot of sense, and this is likely to be what will happen in practice. Moving on now to the second of the three general approaches, software-defined perimeters. I personally regard this as an emerging approach, but happy to be corrected if anyone can point me at any larger scale deployments. The approach originated in the Cloud Security Alliance back in about 2013. Essentially, it is identity-centric access control. An initiating host with an agent establishes a connection or connections to a server or servers as required, basically much like a multi-point VPN, but directed by a centralized controller. And there's also server-to-server based connection options available as well. SDP enables access to those resources based on user-defined controls. The target servers are actually dark until a connection is established, so they're not pingable with no DNS entries. The Cloud Security Alliance actually acknowledges that this is an alternative to NAC and remote access VPNs. So that was one of the reasons I wanted to mention NAC within the earlier micro-segmentation approach. So it's basically a hybrid of multi-point VPN and NAC. In terms of adoptions, it appears to be mostly the small players in this space today, with the main use cases being multi-cloud access and securing administrative access. These are the high-level architecture diagrams, which I have sourced from the NIST 800-207 document. The first with a single resource behind a gateway. And at the subject end, an agent establishes a secure tunnel to the gateway, which then permits access to the resource. And then there is a variation of this approach with multiple resources behind the gateway. Essentially, it's the same thing in principle, but you can get to multiple resources through the one gateway. The third general architectural approach is application access proxies, also known as identity-aware proxies. The poster child for this approach is Google's BeyondCorp. Akamai are also people who have done a substantial deployment based on this approach as well. The key point is that there have been some successful large-scale deployments utilising this approach. In terms of information, Google has provided some very good information in terms of research papers on how they deployed it. From an architectural perspective, this model focuses on identity and access at the application layer rather than at the network layer. An identity access proxy architecture provides access to applications through a cloud-based proxy. Like software-defined perimeters, identity and authorization occur centrally, and they facilitate least privileged access to some particular resource. Like other approaches, a key component is a trusted identity source that can be used to verify the users and devices, who they are, in other words, the authentication function, and what they are allowed to access, in other words, the authorization function. With the identity access proxy approach, applications are typically accessed using standard HTTPS protocols, and this is different to software-defined perimeters, which uses a direct tunnel approach. So with those parameters, you can decide if this approach is suitable for your organization. One of the reasons this was able to be implemented on scale at Google was, as I understand it, most of their applications were web-based. So to wrap up the brief architectural overview of identity access proxies, this is the diagram provided in the NIST 800-207 document. It's fairly similar to the software-defined perimeter example, but it illustrates the gateway without the use of an agent, as occurred in the SDP approach. And then at the top you can see the integration of the policy engine and the policy administrator down to the gateway. So to wrap up, we have seen three main architectural approaches which can be utilised to deploy Zero Trust. In the next video I will provide some practical deployment guidance. And finally, these videos do take considerable time and effort to produce, so likes and comments are greatly appreciated. Thank you.